Hello, welcome to the Night Sky Imaging YouTube channel. I'm going to do something different and look at some data that was sent to me from a member of our Astronomy Club, Roper Mountain Astronomy in Greenville, South Carolina. And the member's relatively new to PixInsight. He's watching all the tutorials that he can, and but he's run into a couple of log jams, as we all do. And so he sent me the data, and he's also kind of new to astrophotography, mostly a visual imager. And not only that, but he's challenged himself to use his 11-inch edge, a terrific Smith Cassegrain, along with his one-shot color camera, which I think it's a ASI 533 one-shot color, which is a great little camera, CMOS camera. So let's look at his data and let's head over there and see what we can come up with. Okay, what I told, I'm just going to call him Sam. We need a name for our member, so we're just going to call him Sam. And I talked with Sam last night on the phone about some of the things that I saw, and 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 it was kind of a learning experience, I think, and I picked up some things as well. But the first thing that I did when he sent me the data was I started blinking through the calibration files. And so I loaded the bias frames, and I have the bias frames loaded now. And I stretched them. Matter of fact, let's just start from scratch and I'll show you where I'm getting all of this. Let's just close out blink for a minute. Kind of jumped ahead of myself. We're going to go to process, all processes, and come down to blink. And we'll just delete this, all of these, take our folder down at the bottom, open, and these are the files that were sent to me. I called them 1-RMA for Roper Mountain Astronomy, and the target happened to be IC 1396. So the folder will have bias, darks, flats, lights, and then I put the masters from my very first run of the weighted batch processing script in this folder right here to be used at a later date. But you can see that I have three other folders, 1-pix, 2-pix, and 3. These are three different runs of the weighted batch processing script. The very first time I ran it, I used all the files that Sam sent me. The second time that I ran it, I went through the bias and the darks and the flats, and I eliminated any of the calibration files that I felt like would not contribute or would have a negative effect on that particular calibration master. And then the very last run of the weighted batch processing script was done with 0 calibration files. I just used the subs. And Sam had an inordinate amount of a lot of amp glow, which is characteristic of some of the ZWO cameras, and which tells me it probably wasn't the ASI 533 camera because it has 0 amp glow. So I'm not sure what he's using. We'll find out though. But these represent the 3 runs, and we're going to look at the data just so if you had any doubts about the need to shoot calibration files, this will help you better understand why. So let's open up bias and let's bring all of these bias frames into Blink. Blink is an old term referring to reviewing your images in a like a blink of an eye quickly. Not only do we want to load them, we want to stretch all of them. Only the first one has any kind of a non-destructive auto stretch. So we're going to click on this top icon and stretch them all. And the first thing I want to do is I want to look at the name that each of these bias frames revealed. One, he took 1 second bias frames, and I can't remember why he used 1 second, but the way to take your bias frames is to use the fastest exposure time your camera is capable of delivering. If you had a Nikon DSLR, that would be 1/5000th of a second. If you have a CCD camera, then they vary. But the CMOS cameras by ZWO, I think they are about 1/3000th of a second, or in that neighborhood, which would be 0.003. I know that I can't run Sequence Generator Pro Flat Wizard and use 0.00 or a bias and run 0.003, but I can run 0.03. But my advice when shooting bias frames with a CMOS camera is to enter 0 for the exposure. Sequence Generator Pro, I would assume Nina, those software programs will run then at the fastest exposure the cameras can deliver at. So at a 1 second bias, you're going to see more electronic signature than you need to see. So, and if we scrub through this pretty quickly, say at take a 0.5, a half a second on each and start. I don't know how visible this is going to be, but let's see if I can't make this a little bigger. I'm opening up all these boxes because, crap. Did it again. We'll say a dirty word. Okay, now that's a little bigger. But you see these lines going across. These represent an exaggeration of the electronic signature of the camera. And this is going to be subtracted from the flat frame. When you run the weighted batch processing script, you're going to have a master bias, a master flat, and once you've done that, the calibration process will subtract the master bias from this frame. And it's going to leave these lines, not quite like this, but it's going to leave some lines in your master flats. So that's not good. And we're going to want to fix that by taking the exposure to the fastest exposure possible, or entering 0 for the exposure time and not 1 second. Also, I noticed that this is a one-shot color camera, and he added more glass than he needed by running a lume filter. So you don't want to put any more glass in front of your bias frame than you have to. You don't want to add anything to your bias frame in any way, shape, or form, but the sensor exposing at the fastest shutter speed in the dark, covered up at the same temperature that you took your darks and you shot your subs. This will deliver the best, most workable and authentic characteristic of the electronic signature of your camera. So that's, I recommend as a change number one. But if we scrub through these, you'll see that this banding is kind of moving throughout the as this thing runs. I don't know why it's stopping. So we want to get rid of that. All right. So those are our bias frames. We'll close that out, kill those pictures, and we're going to open up the darks. And here we go. Now, I'm going to open up, I've blinked through these, so I want to open up the good ones. And I want to open up the ones that I didn't use, which are also these. Okay, so this represents all of the dark frames, and let's scrub through those. You can see the amp glow is reaching well out into his image here, and there's some amp glow going on over here. So let's just move through this. And so far, they look fine until we get to this one. I'm going to back up, and then this one, and the next one. And then they started, I'm just going back and forth here to look at this. So I asked Sam, I said, how are you taking your darks? Are you waiting until the next day and just capping your telescope? He said, no, I try to take them immediately after I take my subs. So I thought, well, somehow or another, light is leaking in. Do you cover your telescope? And he says, I throw a towel over it. So I don't know where the light is coming from, but there is something happening, and all I can think of is there's light that is making its way into the camera. Now, these are 400-second lights. It takes a long time to take 20 or 30 400-second lights. So if you started your lights, let's just say you took light frames from 10 o'clock to 3 o'clock in the morning, and then you set up to take your dark frames from 3:10 until you took all 20 or 30 darks. Well, you'd be into daylight before they would stop, because it's going to take a long time. And so I was wondering if possibly the last few these light frames, maybe the sun was coming up. But at any rate, this is what was causing havoc with this signal, and they just won't calibrate out, and they definitely won't remove this amp glow. So we removed them. I removed them in the run, and when I removed them, it created, it gave us a little better signal, but we had such a small number of darks, we didn't do a whole lot of good with damping down the amp glow. So let's blink through these again, and let's just keep the darks that are acceptable. All right, this one we're gonna get rid of. So let's see, this one, 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 this one. Well, it's this one, this one, this one. All right, so we're going to keep essentially the last of the darks, 400-second darks, were um, somehow or another light infiltrated. How it happened, I don't know. He may have taken his darks the next night and just took a cloudy night to take them, and he said there was a street light nearby, but I don't understand how the street light would affect one but not the rest, or five or six but not the rest. But somehow or another, light affected these, I feel like. Okay, so what we're going to do is just select these, and we're going to go to this icon right next to the scissors, and we're going to move them. I created a folder called Blink, and we're going to move them over, and we're going to close that out. And then we're going to open up the, well, we got to go back to our Blink. Come on, all processes, Blink. And let's delete that. And let's open up our flats. Oh, one other thing I wanted you to see. Let's just bring up one of his dark files. And any one of them, even one of the bad ones. I noticed that he had the hydrogen alpha filter. Well, let's just bring up the fits header. Let's see if fits header will show us. Let's go up here. Yeah, he had the hydrogen alpha filter active when he took his darks. And I don't know if this is right or wrong. I'm clueless, but I'm going to remove all the glass I can remove from my sensor when I'm taking my calibration frames, if I can. Now, if I have a filter wheel on and I've set that up to run kind of automatically, then I'll go to the lume filter. But I would prefer to run my darks at my bias without any of the glass, filtered glass in front of it. Now, that's not the case with flats because we're using flat frames to remove all of the crud and stuff that collects on the optical train, and your filters are clearly part of the optical train. But with darks, I don't think I would have used the hydrogen alpha filter. I don't think it had anything to do with the light coming in. In fact, technically speaking, it would have helped to filter out light. But at any rate, let's bring up our flats. And let's go back to our root and flats. We're going to blink through those. And these looked okay. The master flat showed some of the biased subtraction from it. And why didn't those load? I don't know. All right, we're going to try this again. Flats, they're there, aren't they? I don't know. I don't know what I did. They're going to load now. And we're going to also do an auto stretch on all of them. Okay, now we have run an auto stretch, and he did use this HA filter, and because he did use it, when he took his subs, he did right. He did the right thing. And his exposure time is 1 minute and 54 seconds. Okay. Now, I don't think that's enough time to reveal stuff that may be present in the optical train, particularly when you take an RGB one-shot color camera and add the hydrogen alpha filter to it, because you're really minimizing the amount of light that's going to come through there. And I would have thought this would have been 5 seconds, 6, 8, 9, 10 seconds. So I'm just bewildered at how we have a flat that looks like this. And I'm assuming the histogram is pretty much positioned a little left of center. And he did that with 1.54 second flats. I'm just puzzled. I don't know what ADU that he used, and maybe let's just go ahead. By the way, all of these look about the same. I'll go back to say 1/10 of a second. We'll really speed through those. You can see that the flats all they look sharp. They look flat. Okay. So we're not going to make any changes there, but let's bring up a flat and just any one of them, and let's open the FITS header, and let's see what it's got. The HA filter, and kept the gain the same. The exposure time is 1 point, and I am looking for at 150 gain. He's not at unity. Well, it's not in here. Okay. I'm looking for ADU, and it may be right in front of me, and I just don't see it. Okay, well, I don't see it, but one question that I have for the member when I talk to him is, does he remember what ADU unit that he used when he took those? Okay, now remember I ran the weighted batch pre-processing script 3 times. And the first time I created a directory called 1-pix. So let's open up the sub from there and go to 1-pix. Here are our masters, and there's our light frame. This is our RGB. By the way, I didn't blink through the subs yet, but here's our 400-second dark, and here's our bias frame. So I'm going to open up this sub that is, now this is the high rejection. This is going to remove the satellites that streak through and stars that are figgly or something that didn't fit in. And then This is our low rejection, and so you can see that um, it's an unusual looking low rejection image. I don't know how to interpret it. I just am not used to seeing it. And then here is our sub, and we're going to stretch it. Let's unlink this first and stretch it. And so there we go. So once we ran all of our darks, even with the ones that were kind of messed up, we still have some amp glow here. So this is including all the files that Sam sent me. Now we're going to go to the second run, and that will be Pix 1-Pix, and this time we ran with the darks. We removed the darks that were too light and only used the darkest darks, and we have a little different looking low rejection, more closer to dark. So I even think that the darks that we did use weren't dark enough. So I don't know. I just don't know. I just know this is unusual, and that's what I'm thinking. So let's stretch this. You're going to see more amp glow. And the reason you're going to see more amp glow is because we're only using a few darks. Why did I? Hang on a minute. I made too many copies of this. I didn't mean to make any copies of it. So here we go. We got the image with all of the all of the calibration files. Here's the image where I cut down on the number of darks, and we only, I think, kept 12 or 13 or 14 darks instead of 30 or 25, I think is what it was. So we ended up with half the darks, and as you can see, darks are going to remove the amp glow. So really all Sam needed, all he really needed was a good exposure for his bias, a fast exposure, because you can see the lines going through this image that weren't calibrated out, going this way. They're real faint, but goodness gracious. And he can eliminate those with a faster exposure, and then more darks, and the amp glow will no longer be a problem. And then we ran, now this is with better darks, so we got a better contrast. Let me really zoom in here. Not that much. Right there, and let's do a better comparison. So this is with the amp glow, because of the fewer number of darks, and I'll just drop that on top and put these side by side. So you see better signal here, more contrast, because we have darker darks. Here we have less contrast because our darks are infiltrated with light. Here we have better contrast with our target, but we have more amp glow because we don't have enough darks. So there's some lessons here for Sam and I to acknowledge at least. We need more darks. We need more darks, and we need to make sure that our telescope has no light entering from the top or around the camera, especially around the filtering system, because I'm not sure if Sam is using a filter wheel and he was swapping the lume filter for the HA. I think he does have a filter wheel, or whether he had one of those slide-in filter adapters like Starzona makes. I have one of those for my one-shot color cameras, and especially for my Hyperstar. So, but at any rate, light can get in from your camera, and it can get in from the lens area. So I know he's going to try to make sure that he keeps that from happening. And also, my sneaky suspicion is that when he started darks, it was dark. But when the last dark was taken, it was morning, or the sun was rising. And that in and of itself will affect your dark frames. I know I have done it before. Too many times, as a matter of fact. So I'm picking up on something that I've done. So at any rate, that's the signal. And the other thing I did was I ran it without any subs at all. And now you want to see some really super amp glow killing an image. Let's go to run 3, master, and our RGB file. And here's our high. Here's our low with no darks. See what our low looks like? This is a typical low rejection frame. Let's stretch it. This is what my low rejection frames look like. So there's no darks to screw it up. And I know that's what's happened to him. So now let's zip this open. We have our better contrast than even over, well, that's not where we had it, even over here. Even better signal. But the amp glow here and down here is killed the image. So do you need darks? Yes. Do you need enough? Probably enough plus 5 more. So one of the things I thought Sam may try is to, one, take your darks on a night when you know it's not going to rain, but you're pretty sure clouds are going to keep you from imaging. And so take your darks and your bias or your dark flats all night long. And start out by taking, say, your 400, take 20 of your 400-second darks, then go down to 20 of your 360s and 20 of your 300 and your 280 and 240. And then also say take some darks around 10 seconds. Not darks. Yes, darks around 10 seconds. Because there's a good possibility you're going to want to start shooting your RGB stars at about 10 seconds and take those out of that image and put them into your nebula image. But more on that at another video. At any rate, the point is, shoot your darks when you know you have a dark sky where you can cool your camera on a similar night to when you imaged, and build you a little bit of an inventory and use them until the temperature, ambient temperature, changes significantly. Now, real quick, let's take this image right here that Sam did. As a matter of fact, I'm going to take the image after we got finished with, this is the image with the amp glow that used only the darks that were dark or appeared to be dark. And so we have more amp glow. And so let's go ahead and process this thing very quickly. So the first thing I'm going to do is I'm going to bring out the dynamic crop, and I'm going to crop some of that amp glow out. Now, I don't want to crop our image away, but we do have some artifacts going up here from stacking. I also notice when I blink through Sam's subs that he doesn't dither. Folks, you gotta dither. You just have to dither. When you dither between frames, the mount moves the camera a few pixels randomly, or you may have it use a pattern, but it moves the camera. And when the camera moves, the stars move. And not only the stars, but the nebula, any target that you're imaging, it moves each time you move your camera. What doesn't move is the noise. It's the same whether your camera is moving or not. And so software recognizes that everything that moves when you dither is good, and everything that doesn't move, i.e. noise, is bad. Let's subtract the bad, and let's keep the movable good. And that's how you can remove some of the noise inherent in long exposures. And at the same time, you're able to increase your signal to noise ratio anytime that dithering takes place. So guys, dither. It's a lesson hard learned for me. It takes a little more time. It can even be a headache at times. All right, we're going to crop this. I'm going to go ahead and we're going to do this in a hurry. So we've cropped this image. The next thing that I'm going to do is run dynamic background extraction. I'm going to take this one and move it here. I'm going to move this one away from this real bright star. I'm going to add and I am one that likes to use these big boxes. And so here we go, and we're going to run this twice. I have this already set up, but we're going to run this using division, and I'm going to use this process again. So I'm going to drag this triangle to my desktop. I'm going to delete this. I've got to open it back up again. And this time, let's stretch this. And this time, I'm going to use subtraction. Subtraction helps to remove vignetting. And the division removes the light pollution that is affecting your image, the gradients that are caused by light pollution. The subtraction has a multiplicative effect, and it's just attacking the vignetting and issues that your optical train creates. So we want to run this one time. I got to use this. I keep dragging the triangle. Just hit the execute. Okay, and we're going to eliminate that, and we're going to drag this over to edges. And if you're interested in knowing how I set this up and what my settings are, I have a video on the dynamic background extraction down there somewhere, and just scroll down, and these settings are borrowed from Sean Nielsen at Visible Dark. It's a brilliant idea, and I use that almost all of the time. Now we're going to run a denoise, and I would use these settings. I have a video on how to run multilinear transform. You do this while the image is still linear, and we're going to preview a mask in real time. I want to unstretch the image, and so what you're going to see is the part of the image that's going to have a denoise effect applied to it. If it's dark, it's protected, and I don't want to run noise on the edges, so that looks pretty good, but I may increase it a little bit, and just a little bit more. So I want to protect this part from a noise algorithm, but I want to apply noise direction to everything else but my nebula area and my stars. So I'm going to uncheck the preview mask, and when this stops clocking, I'm going to close the real-time preview. It takes it a second. And delete the real-time preview. I'll restretch the image, and I want you to see there's the noise before, and here's the noise after we run this. Okay, so it made a nice contribution to noise reduction. I'm going to close that out, and yes, I do have Noise Exterminator, and it works really well, but I only want to run this one time, and I'm going to run it towards the end when it is non-linear. If you want to run it twice, you run the risk of having an image that becomes plastic-like, and I don't like that look. So I like the contribution of the MLT denoise. That's what I call it. It's multilinear transform. So now that we have this pretty much noise removed, then let's run a color calibration. I'm going to go up to Script, and I'm going to go down to Utilities, and I'm going to use a feature just called Auto Color. And it's a script that you can download from Sky Pixel's website. It's by Hartmut Bornemann, and it's a brilliant script that runs an auto color process. You can use the histogram transformation. Also, Easy Scripts has a soft stretch. I find that works sometimes, but a lot of times it doesn't work. Okay, it's finished. We want to restretch it. And so we have auto color applied. It looks as though it has exaggerated our amp glow, but worry not. By the way, I just made a boo-boo. I said you can run easy stretch. That's when you're going to do a histogram transformation, convert from linear to non-linear. You can use photometric calibration. I love that. And you can use also color calibration, which is go up to process, all processes, and come down to color calibration. But I like the script by Hartmut Bornemann, and I think it does a really good job of applying a color calibration. So with that being said, it's ready to stretch this image. So what I'm going to do is I'm going to bring up histogram transformation, and I'm going to unstretch the image. This is I got to find this image, and here it is. I've loaded this image. I've selected it right here, and I'm going to bring up a real-time preview, and let's just start stretching. I'm going to drag this over and hit apply. I'm going to reset it. I'm going to drag it over some more, and I'm going to reapply. I'm going to restretch it. I'm going to drag it over some more. Make sure you don't move into this area where you start clipping data. And apply some more. I'm going to restretch, bring this over, and bring this down. And I'm going to reapply. And we're going to restretch or reset. Bring this over. And probably about right there. And I've moved the histogram about as far as I'm going to be able to move it at this stage. So let's close this out and close out our real-time preview. Now what I'm going to do is some selective background work, and the first thing though I want to do though is add some saturation. So saturate this a little bit, and let's change this to IC. Come on. To IC 1396, and let's make a copy of it because I may screw it up. And then I want to go up here and make a luminance appear where it has a red, green, and a blue box. I'm going to click on that and extract a luminance layer, and I'm just going to call this Loom, and I'm not going to make any changes, none. And I'm going to come over here to LRGB, and that's LRGB combination, process, all processes, and just come down here to LRGB combination. I'm going to uncheck red, uncheck green, uncheck blue. All I'm going to check is Loom, and I'm going to bring that in, and I'm going to take saturation and I'm going to drag it down. If you move it down to say 360, that's a good place to stop, and you apply this, you're going to add levels of saturation to this image. By lowering the number, you increase the saturation. By raising the number, you decrease the saturation. All right, we got a little more red. Let's do it again. You also got a little more blue. We're going to get rid of that in a minute. I'm just interested in some color around the elephant trunk. All right, let's run it again. Sometimes I remove the stars before I run this because it has really affected the stars. So let's undo it. I should have done it this time. And let's undo this again. And let's undo that again. All right, let's close that out. I'm going to bring up Star Exterminator. I'm going to generate star image, and I'm going to select unscreen. We are non-linear, so I don't need to check that. And so I'm just going to apply this now. Okay, I paused that so you wouldn't have to endure this, but here's our stars. and we're just going to rename that stars, and I'm going to move this over here, get rid of this, and then this is our nebula. You can see it still has a lot of star remnants. So what I'm going to do is create a mask, and I'm going to go up here to script and render, no, utilities, and we're going to go down to game. I've got game entered twice, and I'm going to make this big, and I'm going to use a multi-point mask. And what I'm going to do is I'm going to make a point there, and make a point about there, and I'm going to drag this in some, and that out a little. Okay, maybe like that. I'm just interested in protecting where I'm pretty sure I'm going to have some color. All right, let's go on out here too. Okay, so let's click OK. I selected gradient, but it'll be a pretty it'll be a pretty large mass. So what I'm going to do is I'm going to drag this and apply this mask, and I'm going to close this out. I'm going to call this a nebula underscore mask. I'm going to use this again. So what I'm protecting is this area right here, and so I'm going to invert this mask, invert, and I don't want to show the mask, so I'm going to get rid of that. I'm going to bring up curves, and all I'm working on right now is the background. I want to dampen it down some, and so I'm going to select RGB/K, and I'm going to drag this way down. Then I'm going to go up here to mask, and I'm going to invert it again, and I'm going to go reset this, and I'm going to do back up, mask, invert, and I'm going to drag this down to about here. I want to kind of darken down the background, and I want to kind of leave this protected by the mask. Now I've got to execute it. Okay, now I'm going to reset it, and now I'm going to invert it, and this time I'm going to bring it up, and I just really want to kind of bring up this area. I'm going to bring up saturation some, not a lot, and let's apply that. All right, let's close this out. Let's close this out. Now, let's remove the mask. Now let's get rid of this loom layer because it has stars in it. Let's get another loom layer that doesn't have stars, and let's call this loom. And we'll put this back over here. Now we're ready to get our LRGB out and add some saturation. So let's close those out. Let's drop this down to, say, 320, and let's apply it. See if we can bring out some of the red. Keep in mind, he had a hydrogen alpha filter in front of a RGB filter, so there should be some red. Won't be a lot, but there should be some. Let's see if we can go get it. and maybe a little more. All right, let's close this out, and let's make another mask. Let's go up to Script and Utilities, Game, and let's let's see. Let's use a an ellipsis this time, and well, first of all, we want to get rid of that, and let's add an ellipsis, and so we're going to hang on a minute. All right, back to ellipsis. Add. All right. Let's get a big screen. We've got some area right here that's blue, and let's add another one. It's down here, and I don't like it. It may be, I think I've just stretched it to the point with curves that I'm bringing out false color. But at any rate, I'm going to create this mask, or these two little masks, and there they are. I'm going to apply them. Oh, I didn't apply them. When you apply, I think I added them to, never mind, it's applied now. And so I'm going to bring up curves. I'm going to get a real-time preview. I'm going to hit the blue filter. I'm going to drag that down. Actually, I am turning it green. So let's just take saturation and drive that down some. And let's apply it. Let's apply it again. Let's apply it again. And let's take, not that much, right there, and apply that. Okay. All right, let's delete, close out, mask, remove, and now let's bring up saturation, real-time preview, and let's click watch what's going to go. I've already have some presets in my process icon separating the colors, so that's why those little dots are there. But I'm gonna run up down here, and I'm looking at this while I'm moving this around. And so my color is right over in here. So I'm going to raise that up. I'm going to reset it. And I'm going to set an anchor point there, an anchor point there, an anchor point there. And I'm going to try it again. All right, reset it too much. All right, anchor point here, here, here. Let's just do that, and let's run it a couple times. Okay, there's some of the hydrogen alpha we've been looking for. All right, let's close this out. See how noisy this beast is. Bad. Let's go ahead and let's run Noise Exterminator now. and let's give it a whirl. And so just drag this. Okay, so we have managed to get rid of some of the noise. I'm going to go ahead and get rid of this amp glow once and for all. I'm going to go back up to Script, Utilities, Game. I'm going to go to ellipses, delete those, and let's just create one right there. That's all we need. And let's apply the mask. And let's minimize this mask. I'm not even going to give it a name. I'll never use it again. There's our amp glow. Let's just keep an eye on that, and let's just drag this down about there. Let's run it twice. Gone. Okay, now it's still there. I could have ran it a third time, but you kind of got the mask. Remove. All right. Let's see what our stars look like. Blue. Okay, let's before we add them back, let's go to curves, and let's just go over to our blue and drag that down just a little bit. Apply it. Apply it again. And now we're getting, let's back up. Now we're getting the green, which will happen. And let's just drag down luminosity some and try to get some of that halo going that way. And now let's bring up saturation. Let's reset the whole thing. Let's bring up saturation and add some color and reduce their size a tad bit. Let's go now to the morphological transformation, and I would use 5 elements one by one. Morphological mean, and let's use this. It's about the third one in, second row, star size, and let's drag this and see what happens to our stars. Not on the real-time preview. Let's try it on our stars. Takes a few seconds. We're halfway there. Run it one more time. Tighten these suckers up. Okay. All right. We may reduce them even more using Bill Blanchard's star reduction, but I don't think we're going to need to. So here's our two images right now. We need to add them back together. So let's do that using Pixel Math. You can go up to Process, All Processes, and come down to Pixel Math. Or I have it over here as a saved process icon. So we're going to use a single expression that's going to be checked, and we're going to click on Expression Editor, and we want to add the IC1396 clone. That's this, and we want to hit the plus. You need plus there, so I hit the plus key, and we want to add stars, and that's all we want to do. Nebula plus stars gives us our image, but we need to go down here. We want to create a new image. We don't want to replace an image. We want to create a new one, and we want the color space to be the same as the target. I'll just go ahead and put in RGB color. Let's just drag it, and let's get our new image. So we can bury that. We can minimize our stars. We can now minimize our clone, and now we've added our stars back, and we are fairly close to being done with all I know how to do. I could take this into Photoshop and selectively do some luminosity masking, which would bring out some of these colors, but I think I'm done. We'll save this image for, we're going to call this now IC1396 underscore ELEPHANT. Trunk. Can't spell. And we're going to save that as a 16-bit. And we'll go over here to RMA. And we're just going to save it as a 16-bit TIFF file. And click 16. And everything else is fine. And we're done. So